Welcome to area of a parallelogram. What is a parallelogram? A parallelogram is a shape that has two pairs of parallel sides. The opposite sides are equal and opposite angles are equal. Let's start with the parallel sides. We'll take essentially what is the top and bottom of my figure. And those are parallel lines. According to the definition, I need a second pair of parallel lines. And in this case, these lines would qualify as parallel. My opposite sides are going to be equal, so the length of my top side and bottom side will be equal. The length of my left and right side will be equal. The final, and less important to us now, but the final piece of defining a parallelogram is that our opposite angles will be equal. When we have parallel lines and equal sides, our opposite angles will be equal. So let's look at A, B, C, and D at the bottom of the page and try to decide which of these are parallelograms. So let's start with A. We have parallel sides. So I think we're good with step one. 1, 2, 3, 4 centimeters. 1, 2, 3, 4 centimeters. 1, 2, 3, 4, 5, 6, 7, 8 centimeters. 1, 2, 3, 4, 5, 6, 7, 8 centimeters. So we have two pair of parallel sides, and our opposite sides are equal. Check. Just by looking at B, I do not have parallel lines. Ultimately, eventually, these lines will cross. So B will not be a parallelogram. C. Looks like I have parallel lines here and here. I've got, if I stretch it from left to right, I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Top to bottom, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I would say C is a parallelogram. D. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our sides are equal. Do we have parallel lines? I think we do. I would consider D a parallelogram as well. We're going to talk about area of a parallelogram. I'm going to ask you to estimate the area of a parallelogram. And the way I'm going to do that is I'm going to count the whole squares and as well as the squares that are shaded 1/2 or greater. So for instance, the square at the bottom left-hand corner is more than half shaded, so I would count that in my estimation. This square on the far right-hand side, I would not count in my estimation because it's not shaded 1/2 or greater. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Skip this guy at the top. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. I'm going to skip him. 34, 35, 36, 37, 38, 39, 40, and 41. So I had 33 whole squares and I have 8 part squares. So my area is going to be about 41 square centimeters. When we talk about a parallelogram, we're going to talk about base and height. If I go back to the first page, shape A is a rectangle. A rectangle has two pair of parallel sides and its opposite sides are equal. So a rectangle can be considered a parallelogram. When I move to the next page and I ask you to estimate the area, we won't talk about area in length times width with parallelograms. What we'll talk about is a base and a height. Any side of a parallelogram can be considered its base. So if we go back, we can call the bottom side of the parallelogram its base. The height of a parallelogram is going to be the length of a line segment that joins parallel sides and is perpendicular to the base. So if I quickly sketch a parallelogram, I have my parallel sides, and I realize this isn't perfect, but if I call this my base, I need a perpendicular line. And remember, a perpendicular line is more of a T shape, where the bottom would be my base. So I need to have a perpendicular dotted line. That is going to be my height. My height is not the side, but this dotted line. So we'll talk about area as base times height. We can always go back and make the connection between rectangles and parallelogram. The area of a rectangle is length times width. The area of a parallelogram is base times height. And for our purposes, the length of a rectangle will be the same as the base of a parallelogram. The width of a rectangle will be the same as the height of a parallelogram. The area of a parallelogram is the same as an area of a rectangle with the same base and height. So I may have a rectangle with a length of 8 and a height of 5, which is 40 square, well, we'll call it units. I may have a parallelogram that has a base of 8 and a height of 5. My area will also be 40 square units. And here's a perfect example of this, where you see my rectangle with a length of 8 and a width of 5. I have a parallelogram whose base is 8 and whose height is 5. Both, again, will be 40 square units. So here's your challenge. Take this parallelogram, and in your notebook, number 1, estimate the area of the parallelogram by counting the whole squares and anything that's shaded more than half. Secondly, find the actual area of the parallelogram by multiplying base times height. And third, draw a rectangle in your notebook with the exact same area. And just a hint, remember, the squares in your notebook are centimeters squared. We'll check that tomorrow.